All right, these are questions number 9 and 10. We'll proceed on with the Fall 18 experiment, or exam. Okay, so this question number 9 is the number with the most significant zeros is blank. So this isn't asking for the most significant digits, but instead the most significant zeros. And so what you can do is let's go ahead and just go question by question. So I'm sorry, answer option by answer option. Answer option A presents 0.0250001. Okay, so the only zeros that are significant here are the ones that are between 25 and 1. This first zero after the decimal place is not significant because that's basically just a placeholder. So we can go ahead and cross those out. And for this, I'm going to write 4. So it gives us 4 significant digits, or 4 significant zeros. Answer option B shows us 2.5100000. Okay, so this one, all of these zeros are significant because they are found after the decimal place. So that's as if you had a digital balance that went to that many decimal places. So for this answer option, when we count those out, there are a total of 5 significant zeros. Answer option C shows us 0.000002510. The only ones that are significant here is this last zero because that's the one at the end after this. Sorry, that one is significant because it's after a decimal place. These first zeros that are immediately after the decimal place, those are just placeholders. So this one only has 1. Okay. Answer option D tells us, well, 2.501 times 10 to the negative 7th. Basically what we're looking at here is a number that is 0.00000002501. So that means those first ones are just decimal or placeholders. So we only have 1 significant zero there. Now this next answer option E gives us 25000000001. There are 1, 2, 3, 4, 5, 6. There are a total of 6 significant zeros here. So our answer is 6. Okay, so if we just kind of count it off, we can go ahead and eliminate C and D very quickly. Then we're left with A, B, and E. Okay, A has 4 significant zeros, so that's out. B has 5. And we're left with E, 6, as our best answer option here. Make sure that you review your significant digits and what makes them significant, the rules and everything like that. Now question number 10. When you look at this, given the following reactions, reaction 1 and reaction 2, this shows us 2 enthalpies of reaction. 2NO yields N2 plus O2, and 2NO plus O2 yields 2NO2. We've got 2 delta H values, negative 180 kilojoules and negative 112 kilojoules. The enthalpy of the reaction of nitrogen with oxygen to produce nitrogen dioxide. So this is telling us our overall reaction. What we want to do is contort 1 and 2 to match this. This is another Hess's law problem. So what we're going to do is manipulate 1 and manipulate 2 so that they match this. And so what we want to do is basically find our products and our reactants. So for this overall reaction, we have N2 plus 2O2 yielding NO2. So what we need to do is we need to find N2 and O2. How do we do that? Well, in answer option 1, we have 2NO as a reactant, and that's a decompositional reaction where 2NO breaks down into N2 plus O2. Now, N2 and O2 are both reactants in our overall reaction. NO is not found at all in this overall reaction. So what we want to do is go ahead and rewrite this one. I'm going to write it as N2 plus O2 yields 2NO. Let me rewrite that. Let me erase that real quick. So that would be 2NO. Okay, I'm going to scribble that out, while at the same time I'm going to write delta H is equal to positive 180 kilojoules. So whenever I do that, I'm going to scribble this guy out. Okay, so that means that I've got my reactants positioned properly. Now let's look at answer option 2. Answer option 2 shows us 2NO plus O2 yields 2NO2. Our goal is to make 2NO2. So now what we can do, since NO2 is a product in reaction 2, let's go ahead and write all our reactants. N2 plus O2 plus my other reactants from reaction number 2, 2NO plus O2 yields 2NO plus 2NO2. Okay. Now, Our goal is to get N2 plus O2 yields 2NO2. And if we look at this reaction, we've got N2 plus O2 plus 2NO plus O2 yields 2NO plus 2NO2. What we can do is we can go ahead and look at, well, we've got O2 and we've got O2. We can combine those. So 2O2 plus N2. 2NO is both a reactant and a product. We're going to cancel one another out, so we can cancel those out. So now we're left with N2 plus 2O2 yields our other product, 2NO2. Okay, that's great. We've figured out how we need to manipulate this. Now all that we need to do is come up with our delta H for this. Did we need to multiply anything by a factor of 2 or anything like that? No, we didn't have to worry about that. Our delta H for this overall reaction is going to be negative 180 plus, or I'm sorry, positive 180 plus negative 112, which that's basically the same as 180 minus 112, which would be positive 68 kilojoules. So we can look at our answer options, and we're left with answer option D, positive 68 kilojoules, as our best answer option. I hope this is helpful, and we'll move on to some more problems in just a second.